Now I want to talk a little bit more about just vocab and terms that we use with those algebraic expressions. And the first vocabulary word is actually the word term. And a term, or the terms of an algebraic expression, are those parts that are separated by the addition symbol. So it's all the stuff in between the addition signs. For example, let's say we have the expression 7x minus 9y minus 3. We can rewrite that as 7x plus negative 9y plus negative 3. So subtraction and adding a negative are the same thing. So we can change those over just to make it a little bit easier to see those terms. So we have three terms here, 1, 2, 3. So it's the 7x, the negative 9y, and the negative 3. Now, the numerical part of a term is called the coefficient. It's just the number out front with the variable. So if you have the term 7x, 7 would be the coefficient. You have negative 9y, negative 9 is the coefficient. If there's no number written in next to the variable, then there's always a 1 there. So the variable x is really 1x, and negative x is really negative 1x. So we tend not to write the 1 in, but it is there. Now, if your term is just a number, so if it doesn't have a variable, instead of using the word coefficient, we actually use the word constant there, or numerical term, but I would say constant is used more frequently. So in our expression here, the constant is the negative 3. Now, the parts of each term that are multiplied are called factors. So remember, factors are things we multiply. So for 7x, 7 and x are the factors. You do remember that if there's no symbol in between, that there is implied a multiplication there. So we do have multiplication. And one last really important definition, like terms. Now, like terms that are terms that have the same variable factors. So they not only have the same variables, they also have the same exponents on the same variables, right? So the variable part is exactly the same. So examples are 3x and 7x. Now, this is an important concept, so I just want to review a couple more examples of like terms versus unlike terms. So we have one example of a like term here, right? 3x and 7x. We can see they both have the same variable component. Now, something like this one, 3x and 7x squared, these are unlike. They have the same variable, but the exponent has changed. So one is an x and one is an x squared. So those are different things. So these have different exponents or different powers. So another example of like terms, maybe we have negative 6x squared and 4x squared. All right, so now we have the same variables with the same powers. Something that could be unlike could be negative 6x squared and 4y squared. So although these have the same powers, they now have different variables. So they're different types of things. We cannot add or subtract them together is what we're going to see. Now, one last thing is usually when we have variables, we tend to write them in alphabetical order. That's just standard notation, but you don't have to. So for instance, something like 2xy and negative yx are actually like terms. They both have an x, they both have a y. And again, that negative is fine. There would be a 1 there in front, so it does have a coefficient. Something that would be unlike is if I had something like 2x squared y and negative y squared x. So here we have the same variables, x and y. We have the same power too, but that power jumps. Notice that over here, the power is on the x squared, and over here, the power is on the y squared. So these are actually different kinds of things. So these, again, actually have different powers here on the variables, right? So I know the power is the same, but it's not the same on the variables. This one has an x squared, this has an x. This has a y, this has a y squared. So for them to be the same, they both have to be x squared or they both have to be y squared. So these are unlike terms. And again, what we're going to see is that we can add or subtract like terms, but we cannot add or subtract unlike terms, which is very similar to fractions, right? We kind of need common denominators there to add or subtract. Very similar idea here. They need to be the same kinds of things to add or subtract. Now, there's other properties that we do use as well. So I'm just going to do a quick review here, because these are properties that you have likely already seen, Oh, that did not focus. Here we go. And you probably use without even realizing it. So your first set of properties are your commutative property for addition and multiplication. And what these say is that the order in which you add or multiply doesn't actually matter. So for instance, if I add 4 plus 2, I get 6. Or if I add 2 plus 4, I still get 6, right? The order doesn't matter. Same thing for multiplication. If I do 2 times 3, I get 6. Or if I do 3 times 2, I also get 6. So that's the commutative property. I will say that this is not true for subtraction and for division. Okay? Actually, this associated property as well. So this is very specific to adding and multiplying. Now we also have the associative properties for addition and multiplication. And this one's about grouping. So it says that it doesn't matter how we group our terms, we can add them or multiply them, and we still get the same answer. So for instance, let's say I did 4 plus 2 plus 3 and 4 plus 2 plus 3. So I have them in the same order, but my grouping has changed this time. Well, 4 plus 2 is 6, and 6 plus 3 is 9. And then here, 2 plus 3 is 5, and 4 plus 5 is 9. So we get 9 in either case. And the same thing works for multiplication. If I do 4 times 2 times 3 versus 4 times 2 times 3, 4 times 2 is 8, and 8 times 3 is 24. Here, 2 times 3 is 6, and 6 times 4 is also 24. So these properties hold true. Now, when you start mixing operations, like combining them together, then you still need to follow the order of operations. So these properties work within just addition or within just multiplication. Once you start combining things together, you definitely need to still go back to the order of operations and follow those rules. Now, the last piece, and this is something that we kind of formalize a little bit more, which maybe you don't use in your day-to-day life, would be the distributive property. And that says that if we're multiplying something by parentheses, we can distribute that multiplication throughout the parentheses. And then if it's an addition sign, we just bring that over. If it's subtraction sign, we can just bring that over. So we're multiplying through. So for instance here, I take that 5 and I multiply it by all terms inside the parentheses. So 5 times 3x gives us that 15x. Then there's my plus sign, and 5 times 7 is 35. Same thing here. 4 times 2x would be 8x. My minus sign, and then 4 times 5 would be 20. So we can multiply that outer term throughout the parentheses as long as we hit all terms on the inside. All right. Now, the process of adding and subtracting like terms while applying the above properties is called combining like terms. So when we add or subtract like terms together, we just use the word combining. So we combine like terms. We also like to use the word simplify. So simplify just refers to any sort of process that makes the problem simpler, right? So clearing your parentheses, combining like terms, etc. So let's simplify our expressions here. And that's what we do with expressions. We simplify them. We don't necessarily solve them to get an answer. We just kind of clean them up to get them in the best form we can. Now, when you have parentheses, you do start with parentheses here as well. So I know this is a little different than the order of operations, but we still like to always begin with parentheses. I would say like 99% of the time. So start there. Now, I cannot combine anything on the inside because these are unlike terms. We can only add or subtract things that are the same. So I start by distributing. 5 times 3x is going to be 15x. And I have the minus sign. And 5 times 7 is 35. Now I'm just going to bring down this minus 6x and just keep everything in order. It is important that I don't change the order, particularly because of subtraction and division. Those are not commutative or associative. So if I move things around, I could get the wrong answer. Now I do want to combine my like terms. So notice here that I have a 15x and a minus 6x. These are the same kind of thing. They both have the x's. So I can add them or subtract them in this case together. So 15x minus 6x is equal to 9x. Now make sure you watch your signs. That minus or that negative is with the 6, so it has to get included here. So it becomes 9x, and then here I have a minus 35 left. These are unlike terms. I cannot subtract unlike terms, so this is as good as it's going to get. For the next one, let's try that one more time. There we go. So again, we start with parentheses. If I look inside the parentheses, I don't really see anything I can do. I have an x squared and an x term. Those are unlike. I know they have the same variable because the powers are the same, I can't add them. I do want you to notice that multiplying and dividing are fine. We actually can multiply and divide if we don't have like terms. I'm doing it right now, right? But I cannot add or subtract if I don't have like terms. So I'm going to go ahead and distribute first. 6 times 2 is 12, so this becomes 12x squared plus 6 times 4 is 24, so 24x. 10 times 4 is 40, so 40x squared. And 10 times 3 is 30, so I have 30x. Now I can go ahead and combine my like terms. I see a 12x squared and a 40x squared. That's going to go ahead and give me 52x squared. And then I see a 24x and a 30x, which is going to give me 54x. Now these are not the same thing, so I cannot add them together, and this is going to be my final answer. And for my last example here, notice that we do have brackets and parentheses. So we're just going to work inner to outer just like we would with an order of operations problem. And when you see a minus with parentheses, you can think of it two different ways. So one thing you can do is always remember that there is a 1 there. So if you want to, you could write that 1 in there, which may help you with the distributive property. So you're going to end up distributing a negative 1, not just a positive 1, because it is a minus. This is really like adding a negative. So we're going to distribute a negative 1 here throughout. The other way you could think of this is that a negative sign, all it really does is it changes the sign of every term within the parentheses. So if it's helpful to put that 1 in and use the distributive property, then go ahead and do that. If it's not, though, then just remember that what's going to happen is your signs are just going to change. So instead of being a positive x, it's going to be a negative x. And instead of being a negative or a minus 3, it's going to be a positive or plus 3. Now, negatives and subtraction are basically the same thing. So you can use them interchangeably. And you'll see me do that here. So I think I called this minus sign a negative. It's the same idea. So minus 3, plus 3, negative 3, positive 3. It's still that same change. Now I am going to clean up inside my brackets first because I do actually have like terms in this case. 5 plus 3 is 8. And again, this looks a little funny because it's a bracket, but they work the same way as parentheses. So if I have a 2 touching the brackets, this is multiplication. I'm going to apply that distributive property. 2 times 8 is 16. And then 2 times negative x, so I can either write this as plus negative 2x, or if you wrote this as minus 2x, that is fine as well. Again, there is a 1 here, so if you're having trouble, put that 1 in. 2 times negative 1 is negative 2. Finally, I'll combine my like terms. 8 and negative 2 gives me positive 6, so this becomes a 6x plus 16. And we are finally done. So we've cleaned out our negative here, distributed that through, that changed our signs over. Always check for like terms before you go on to the next step. It's just going to make your life a little bit easier if you do that stuff first. So we combined, then we use our distributive property here, and then finally looked again, combined like terms one last time, and we have our final result.